Said that, I want to welcome you to today's class, chapter 6, the five nines. The five nines. Okay. Now, what is the five nines and why is it important? Okay. And the whole essence of the five nines has to do with the availability of our services or of our network, all right, to the clients. And we're going to look at the concept of high availability. We're going to be looking at how to improve the measures we're going to use to improve this availability. And then we're also going to briefly look at incident response and disaster recovery. Okay, so the five nines means that systems and services are available 99.999% of the time. Okay, your system, whether your network or your servers or whatever it is, that it is always available. The point is we're trying to reduce the number of downtime. So it means that both planned and unplanned downtime is less than 5.26 minutes per year. That is the whole item. So high availability refers to a system or component that is continuously operational for a given length of time to help ensure high availability. So we estimate single point of failure, design for reliability, and detect failures as the root cause. Now, although the cost of sustaining high availability may be too costly for some industries, several environments require the five nines. Okay, especially the finance industry needs to maintain high availability for continuous trading, compliance, and customer trust. Okay, the healthcare facilities requires high availability to provide round-the-clock care for patients, right? Then the public safety industry includes agencies that provide security and services to the community or state or the nation. Then we have the retail industry that depends on efficient supply chain and the delivery of products to customers. Disruption can be devastating, especially during the peak demand time. So now, what we are saying here is that if you have companies like banks, that runs financial transactions, you have where they do forex trading, where you have any financial institution, all right, where you use your ATM and things like that. Anytime there is a network failure or there is a service failure in any form, it affects the end user and the company at large. And so availability is very key in such a case. Also, when you have issues when you are dealing with healthcare, all right, or when you are dealing with security agencies, there are areas that you cannot afford any downtime. So threats to availability always are there, all right, because whoever that is trying to cause you harm or malicious intention towards you is capitalizing on this downtime that you're going to have. So there are different types of threats to high availability. The threats can range to failure of mission capital application to servers, all right, to storms such as hurricane or tornado. Threats can also include catastrophic events such as a terrorist attack, all right. Then you also have designing a high availability system. High availability incorporates three major principles to achieve the goal of uninterrupted access to data and services. So elimination or reduction of single point of failure. So system resiliency and then fault tolerance. These are some of the elements you're going to do in designing high availability. System tolerance, system resiliency, and elimination of single point of failure. Now, what are some of the measures we are going to take to improve this particular availability? And one is called asset management. An organization needs to know that hardware and software assets they have in order to protect them. So asset management includes a complete inventory of hardware and software within your system. This means that organization needs to know all of the components that can be subject to security risk, which includes every hardware like your routers, your switches, your desktops, your laptops, your cameras, your biometric devices, and things like that. Every operating system, whether it's Windows or Linux or Mac or whatever operating systems you're using, every network device operating system, whether you're using iOS, like Internet Operating System for Cisco devices, whether you're using a router OS, like for Microtik devices, whether you're using Junos, which is like for Juniper devices, or whatever operating system, network operating systems you're using. Every software application, whether office applications or graphic applications, whatever application, all firmwares, all language routine environments, and individual libraries. All these are things that you need to take stock and take note of, that they are running on your organization. Okay. Now, asset classification assigns all resources of an organization into a group based on the common characteristics. So an organization could apply an asset classification system to document, records, data files, and disks. Then asset standardization. As part of an IT asset management system, an organization specifies the acceptable IT assets and meets its objectives. Then we have threat identification. All right. Now, uh, the United States Computer Emergency Resilience Team and the U.S. Department for Homeland Security sponsors a dictionary of common vulnerability and exposure. All right, we call them CVE. All right, the CVE identification contains a standard identifier number with a description and reference to the related vulnerability reports and advices. Then risk analysis. This is the process of analyzing the dangers posed by natural and human caused events to the asset of organization. And I want you to know that all these measures that we're looking at is just to maintain what? High availability. So that you want to reduce the downtime that you have. Then mitigation. Mitigation involves reducing the severity of the loss or the likelihood of the loss from occurring. Many technical control mitigate risk, including authentication systems, file permissions, and then firewall. How about defense in depth? It will not provide an impenetrable cyber shield, but it will help an organization minimize the risk by keeping it one step ahead of the cyber criminal. So to make sure that data and information remains what? Available. An organization must create different layers of protection. So a layered approach provides a most comprehensive protection. If cybersecurity criminals penetrate one layer, they will still have to contend with several more layers, with each layer being more complicated than the previous one. So layering is creating a barrier of multiple defense that coordinates together to
Hello,
prevent
hello, sir.
attacks.
Hello, sir.
Yes.
Yeah, hello, sir. So I want to plead for with you, sir.
Okay.
That you should.
Okay, so what we were talking about is we're talking about the measures that we are going to use to improve the availability of our services or our systems for users. And the idea is talking about the 5 nines, meaning that your systems or your services should be available 99% of the time, 99.999% of the time. Okay, so and while we were looking at that, we were looking at depth, defense in depth. All right. So on the defense in depth, we just talked about the layered approach. And in the layered approach, we are saying that it is best to provide multiple security measures at different layers within your network or within the services. So in case somebody has breaking one layer, you still have more layers coming up. And then we have limiting access to data and information reduces the possibility of a threat. So an organization should restrict access so that users only have the level access required to do their job. All right. Now, this is like in best practices because we believe that everybody should not have the same rights and privileges in any organization. The reason is for accountability, and the fewer people that have very complete information, the better for the security in the organization. Then we have diversity, which refers to changing the controls and procedures at different layers. So, breaching one layer of security does not compromise the whole system. So, an organization may use different encryption algorithms or authentication systems to protect data in different states. Okay. Then you see we have talked about layering. Okay, and in the layering we're talking about putting different layers of securities at different levels. Then we have talked about limiting. Limiting has to do with limiting the access of users to certain services and resources within your organization or within the network. Then we have talked about diversity, so that we do not use the same login information or the same login system or the same encryption algorithm within your network. That way, it makes it a bit more strong. Then the next one is obscuring. Obscuring information can also protect data and information. An organization should not reveal any information that cyber criminals can use to figure out what version of the operating system a server is running or a type of equipment is using. Okay, so this is very, very important and very critical, especially those that are system administrators. Okay, then simplicity. Simplicity is the last one. So complexity does not necessarily guarantee security. If the process of technology are too complex, misconfigurations or failure to comply can result. So simplicity can actually improve availability, right? So as being cyber professionals, it is not in best practice that everything should be very complex. No, 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 no. It is always advisable that you make it simple but but dynamic and secure. Okay, that way you can be very safe. Now, the next one we're looking at is the concept of redundancy. Right? The concept of redundancy. So a single point of failure can be identified and addressed. A single point of failure can be specific piece of hardware or process, a specific piece of data, or even an essential utility. So a single point of failure are the weak links in the chain that can cause disruption of the organization's operations. So generally, the solutions to a single point of failure is to modify the critical operation so that it does not rely on the single element. So redundancy has to do with having backup upon backup or alternative routes or alternatives to a particular service. For instance, if you have internet service provider, it is always best to have multiple internet service provider just in case one fails, you have a redundant link. Or if you have a server that a service that is on a server, and you can have redundant links to that particular server so that in case there's a problem, you are safe. Or even that particular machine, you can have redundancy. So the whole idea is if you have redundant services or devices, it helps you to be able to maintain your service, your uptime, so that your downtime will be reduced. So the N+1 redundancy ensures system availability in the event of a component failure. You see, we're dealing with digital devices, and so any one of them can have a problem at any point in time. It can be a switch, it can be a router, it can be a server, it can be your camera, it can be your DVR, it can be any device so far it's an electronic device. And so the core and critical devices need to have what? Redundancy. So a redundant array of independent RAID combines multiple physical hard drives into a single logical unit to provide data redundancy and improve performance. These are basically for servers. So when you have a server that has multiple multiple drives, okay, when you have a server that has multiple drives, it is always good to have it in RAID, meaning that logically it's going to be one, but physically you have a lot of it. So that way, even if one particular hard drive has a problem, while you rectify it, you will not have a downtime. So RAID takes data that is normally stored on a disk and spreads it out among several drives. If any single disk is lost, the user can recover data from the other disk where the data also resides. So RAID can also increase the speed of the data recovery. So using multiple drives makes retrieving requested data faster instead of relying on just one disk to do the work. So a RAID solution can either be hardware-based or software-based. So the following describes how it stores. We have the priority, and that one, it detects data errors. And then you have the stripping, and that one writes data across multiple drives. And then you have the mirroring, which stores duplicate data on a second drive. Okay. Then another thing in redundancy is what we call the spanning tree. You see, when you have a network, for instance, and you have switches within that network, and you see these switches are interconnected in this way, it means that there is a tendency you're going to have a loop because you have done redundant things, which is good. These are redundancy that you have created, which is good. All right, so that in case one link fails, traffic can always go out to the other one. That is understood. But there are instances when it will create a loop. Okay, when we come to talk about CCNA2, you will see a lot of that. So it will create a loop so that your frames or your data will continue to loop and loop. So spanning tree now is a protocol that prevents this particular loop from happening. And how does it do that? It looks at the particular ports that are there and blocks the one that is on the redundant link. It blocks it so that there will be no loop. But the moment there is a failure in any of the other links, this one will automatically open. This link will automatically open itself so that traffic will be going through. For instance, if PC1 here wants to talk to PC4, it comes to this switch, and from this switch, it comes to switch 1 and then goes to PC4. This is because this link has been blocked by spanning tree. But assuming this link goes down, for instance, this PC will come to here, PC2, and then instead of coming to switch 1, it will go to switch 3 before switch 1, and then before it gets to switch 4. So that is the part of spanning tree in terms of redundancy. Then another concept that that helps is what they call the first hop redundancy protocol. And in the first hop redundancy protocol is that you have a services in the cloud or your internet service provider, and your traffic has two routers. Your network has two routers. This is maybe router 1 and this is maybe router 2. You have two routers. Now with these two routers, you now create a logical router. This is not a physical router. This one is a physical router. This one is a physical router. But this is a logical router such that it is going to be the default gateway for all these switches. Now, this logical router is created in this physical router and is also created in this physical router. So when this PC 1 to 4 want to send any information to the network, they have a default gateway stored in their PCs. Now, the default gateway is where this particular PC is going to forward the traffic going out of that network. So the point here is that in case this particular link fails, this particular router still has the same default gateway, and then is going to use this particular router in case this router fails. But if this particular router, because this is the standby, fails, then the main forwarding router comes alive. So you have a forwarding router and you have a standby router. And then the forwarding router, in case it goes down, the standby router takes place. So that is the concept that also help. All right. And all these things, like the hot standby router protocol, provides high network availability by providing the first hop redundancy protocol. That's the one I just explained. Then you have the virtual router redundancy protocol. It runs the VRP protocol in conjunction with one or more other routers attached to the local area network. In a VRP configuration, the elected router is the virtual router master, and the other routers are as backup. Then you have another concept called the load balancing protocol. The gateway load balancing protocol protects data from a failed router or a circuit like the HSRP and the VRP, while also allowing load balancing between a group of redundant routers. So all these concepts that we're talking about are ways of providing redundancy to your network such that you will maintain high availability. Okay. Location redundancy. An organization may need to consider location redundancy depending on its needs. So the following analyze three forms of location redundancy: the synchronous, the asynchronous replication, and the point in time replication. All right. Now, system resilience. System resilience defines the method and configuration used to make a system or network tolerant of what? Failure. So routing protocols provide resiliency. So the resilient design is more than just adding redundancy. Resiliency is critical to understanding the business needs of the organization and then incorporate redundancy to create a resilient network. All right. So the second to the last is incident response phase. And in incident response phase, it defines the procedures that an organization follows after event occurs. When an event occurs, maybe a network breakdown or maybe a server breakdown or whatever it is, you have a disruption of your services. How do you record these particular incidences? The first one is preparation, planning for the potential incidents. Okay. Then the second stage is detection and analysis. You discover the incident. The third one is containment and eradication and recovery. Efforts to immediately contain or eradicate the threat and begin to recover. Okay. Then the fourth one is post-incident follow-up. Investigate the cause of the incident and ask questions for better understand the threat. So if somebody now gain access to your network and then causes this particular problem, either to cause a system to shut down or a server to be not to be accessed, or steals a record, or whatever malicious activity that takes place. These are the process that you can do for the incident response. All right, to report it. And then you have technologies that can help you to do this particular incident reporting. The first one is network admission control, and it allows network access for unauthorized users with complaints system. A network complaint system meets all the policy requirements of the system. So different, it's like a supporting or like a ticketing system that you can have. Then you have the intrusion detection system, which monitors the traffic on the network. All right. So as the traffic passes through the network, the IDS actually monitors and informs you. Then you have the intrusion prevention system, which operates in inline mode. it can detect and immediately address a network problem. So when you have a firewall in your network, both the intrusion detection and the intrusion prevention system is usually advised that you let them be up. Then you have the NetFlow IP FIX. All right, this one is for Cisco technologies, and it provides statistics on packets flowing through your Cisco router or your multi-layer switch. All right, then you have the advanced threat intelligence. Now, all these things are devices, they are technologies, they are devices that you can purchase or you can configure for you to deploy it on your network to help you in keeping logs or incident reporting when it comes to network downtime or threat management. All right. Now, disaster recovery. Now, we have different disaster recovery. The most important thing is to plan for them. You have the natural disaster and you have the human caused disaster. And the natural disaster is maybe caused by maybe earthquake or landscape or volcanoes. These are disasters that happen based on natural phenomenon. All right, you didn't plan for it, but it happens. And as it happens, you should not be able to lose your record. You should not lose your data. Then you have the human caused disaster, which is labor events like strike, like walkout, like shutdown, or social political events like vandalism, blockade, protest, sabotage, terrorism, and war. So all these things are human, and when they affect your data of your organization. So when you have a recovery system, you should be able to restore or recover your information or data that you have. Okay. Business community planning. Need for business community. So business continuity, sorry, continuity, not community, is one of the most important concepts in computer security. Even though companies do whatever they can do to prevent disaster and loss of data, it's impossible to predict every scenario. It is important for companies to have plans in place that ensures business continuity regardless of whatever it is that occurs. All right. So the concept is that if you are providing services to your client, irrespective of whatever is happening to you, your services should continue and you should be able to plan for it. And what are the considerations that you should make? First of all, documenting configurations. All right, make sure you document all the configurations you have on your routers, your switches, your servers, and things like that. Then establish alternate communication channels. This is especially needed when you have a downtime, all right, in any of your channels. Then you need to provide power. Very important in IT, all right, you need that. Then identifying all dependencies for application and processes. And finally, understanding how to carry out automated tasks manually. All right. You know, we're in a digital age, and a lot of things is being automated. All right, but it's always good to know it manually. Now, what are some of the best practices that we can the best practices that we can apply? All right. The first one is write a policy that provides guidance to develop the business continuity plan and assign rules to carry out that. All right. Number two, identify critical system and processes and prioritize them based on necessity. Then three, identify vulnerabilities, threats, and calculate risk. Four, identify and implement control and countermeasures to reduce the risk. And then five, diverse methods to bring back critical system quickly. Then six, write procedures to keep the organization functioning when in a chaotic state. And then seven, you test the plan. Then finally, eight, update the plan regularly. So that way, even when you have a problem or a network downtime or a disruption of service delivery, you are still okay. You do not have uh, much problem. So in summary, what we're able to look at is that the chapter explains the concept of the 5 nines, which is you should have your services running 99.999%, which means within a year you are allowed to have a downtime of 5.26 minutes, 5.26 minutes in an entire year, a total downtime if you combine it together, 5.26 is okay. Then we also discussed the various approaches that organizations take to ensure system availability. We also saw the solid system design to include accommodating measures that provides redundancy and resiliency so that organizations can recover quickly and continue their operations. And then we also discussed how organization responds to an incident by establishing procedures that it follows after an event occurs. All right. And we finally concluded with the discussion of disaster recovery in business continuity and planning. Okay. So this is the lectures. This is the class that we have today for chapter